Dem dry bones mean money for a Red Hill, Surrey firm that makes plastic skeletons for medical minds to feast on. And the creepy craftsmanship here means they're perfect in every detail. For the soft plastic, worked with the ease of a child playing with plasticine, is pressed into molds cast from the genuine article, real human bones. The plastic is hardened in an oven. A hot pot of horror for most, but for the people who work here, the best way of cooking up that feeling of authenticity. The first plastic skeleton was made by this firm in 1949, but the foundation of such an industry must surely be attributed to the two gentlemen of Glasgow, Messrs. Burke and Hare. If the two gentlemen of Glasgow sounds like a Shakespearean piece, it's interesting to note that there's a theatrical demand for bare bones. Producers of Hamlet particularly come here when casting. A bone or not a bone? That's the question you're seeing answered. They're not pygmies, just miniatures for use in schools. All the skeletons made here are fully articulated. That doesn't mean they can talk, it means they can fold their arms and cross their legs and run about and yawn, or they could if they had that essential gift called life. Because of this, all the bones are made separately. It's surprising the number of people, apart from medical students, who have a use for this preternatural product. We've mentioned the theatrical demand, but people in other professions have a skeleton in the cupboard. Shoe manufacturers, for example, who buy feet. Putting teeth in is almost as difficult as pulling them out, except that the patient feels nothing. You need a brain to feel pain, but these are, strictly speaking, boneheads. But the firm has also built up a reputation for making every part of the human anatomy. Many plastic skeletons are sold to American hospitals, but sales, in fact, stretch all over the world, for only Egypt and Russia still allow human skeletons to be sold. So it's a pretty safe bet that today the man with a skeleton in his cupboard or car is quite a harmless individual.
One woman whose work is really never done is Mrs. Jean Critchfield of Greenford, Middlesex. For in addition to the common chores of a busy housewife, Jean has a hobby that is most uncommon. In fact, she's probably the only woman in Britain who can claim to make clay pipes by the thousand a week. Using hand-rolled Devon clay and 25 different molds, Jean and her husband Ralph make all sorts of clay pipes, from children's bubble pipes to church wardens. A bicycle spoke pierces the smoking channel, and then the clay is molded, dried and fired for about 7 hours in a kiln. Jean learned her unusual craft from her husband before they were married. Clay pipe making, she found, was a Critchfield tradition, handed down by the family through generation after generation from the time of Sir Francis Drake. Between them, they make 120,000 pipes a year. There's still a big demand for them, short stems for the Midlands and the North, long stems for banquets, and brightly coloured ones for children everywhere. The only pipe that Jean can't make is the church warden. Her hands are not big enough. Ralph uses a mould to make them that is 250 years old, handed down with the secrets of the trade. Whether we smoke or just blow bubbles, we can all appreciate the contribution of Jean Critchfield, the woman who makes clay pipes and helps keep alive an old British craft. It's a small world we live in, but at a West London studio which specializes in making scale models, you really feel like Gulliver in Lilliput. Trees are made of sponge rubber in this model of the Harlow housing scheme. The model was made at the request of the architect to assist him and the Harlow Corporation in future planning. Authentic to the last detail on a scale of 16 feet to 1 inch, it took 450 hours to construct. Started 20 years ago by Ken McCutcheon, the firm has since reconstructed in miniature many famous projects, including the new London airport. Larger still is a model to a scale of 200 feet to 1 inch of the Kuwait oil refinery, showing tankers in the port of Mina Al Ahmadi. Expert Ralph Whitten needs tweezers to set in position the bridge of a tug only 5/8 of an inch long, and to find a mast from a hog bristle brush. Most men are scared of losing their hair, but for the sake of art, 16-year-old David Austin makes use of his. He finds a strand makes an ideal cable for the tiny but correctly proportioned derrick. A masterpiece of detail, the layout, including the refinery itself, took more than 1,000 hours to complete. In the port, the world's largest tanker, World Glory, made of perspex, is the center of attraction.
Swords. Just who would want these old-time weapons of war? In fact, they're now only a colourful part of military and political ceremony. But this has made little difference to the craftsmen who still retain many of the traditional sword-making skills. There's perfection at every stage, even in the casting of the ornamental brass hilts and handles. The hardened brass, like some press-out piece from a child's constructional set, is only the first hint of craftsmanship. That comes into its own with the making of the blade, although the shaped rollers are an automated version of the old blacksmith's hammer. A 12-inch bar of sword steel will double its length in these rollers and come down to a 1/4 inch thickness. It's not until the fingertip stage of sharpening the blade that the sparks really begin to fly. It's a job where you must always keep your eye in, because there's no machine to do it for you. To harden and temper the sword, it's dipped several times into whale oil, then afterwards into molten lead. There's a final twist or two in the clamp to make sure of that eye-inspecting straightness. Strange as it may seem, there's a test which looks capable of blunting, if not ruining a new sword. Yet it's often the steel block that suffers a few chips. Patterns are really the same on swords these days. British colonies winning independence often order swords, and there's a new craze among business companies to have one specially designed instead of a plaque or house flag. All the hand-painted care and design which goes onto the blade deserves the guarantee of complete preservation when it's given a final coating of gold, silver, nickel, rhodium or chromium. Only the handles and scabbards remain to be fitted. In this way, the astonishingly high number of 5,000 swords a year are made. So many fighting blades, yet so few now raised in anger. It's strange, isn't it, that in this modern world of ours, which has brought vast technical progress, there's a flourishing financial future in scrap, model cars and swords. History will always find a place for these museum pieces of the fighting past, as they have in one factory where, in an impressive collection, the famed Sword of Stalingrad earns pride of place.
And a preview of next year's men's hats, which, as you'll have gathered, are going to be a little brighter. First, meet artist Harry Lamplow, who's been designing hats for 25 years, although quite frankly you'll never see his name among the more elegant hatters of the fashion world. Now let's introduce the man who dictates what the well-dressed man will wear, Mr. Alan Bangham. This, by the way, is one place where you can do that to the boss and get away with it. For at this factory in Walthamstow, London, the hats they make are party hats. This is the first stage in making the papier-mâché sort. The basis is wood pulp beaten into a fine mixture to which various stiffening materials and dyes are added. A more unappetizing recipe it's difficult to imagine. But then, quite simply, in one process, the molding machine, it's transformed into an attractive hat. Cowboy style for extroverts and something a little quieter for the rest of us. This must be the only ascot topper in the world for 1 and 6p. Wonder how far you'd get with it in the members' enclosure. Next stage is the drying ovens through which the hats pass for about 40 minutes. Then they're unloaded and have the final trimmings added. The other side of the industry is the manufacture of paper novelties like this dragoon hat made by Mrs. Florrie Perrin, who's been doing this kind of work for 30 years. In fact, it's largely due to the skill and efficiency of workers like her that the industry has beaten off the challenge of Germany and Japan. Today, 40% of production is for export. There's nothing new about false noses, but they're still as popular as ever, and they're made here by the thousand. Similarly, blowouts are always in demand, and this is testing by automation. Toy trumpets come off this machine at the rate of 3,600 an hour, an illustration of the tremendous demand there still is for the simple things that never fail to make us laugh. From brand new bowling alleys to, no, not miniature bowls, but a production line of electric light bulbs. Objects taken so much for granted that about the only time they attract attention is when they fail. One of the first steps in this exceedingly complex task, carried out in a factory in Wembley, London, is to take a carefully measured portion of tungsten powder and sprinkle it into a mold prior to pressing. What, and you may well ask, has a tremendously hard metal like tungsten got to do with a fragile thing like an electric light bulb? The answer, as you'll see, lies in the filament, the bit of wire inside the bulb that actually makes the light. After sintering, the bars are swaged. In ordinary English, this means that the metal is cooked at enormous temperatures, then reheated and automatically hammered on all sides in a series of machines until it becomes a rod which gets thinner and thinner as it travels down the line. Finally, after some 50 different processes, the tungsten is about half as thick as a human hair. One of those bars you saw eventually makes about 5 miles of filament wire. From now on, the pace quickens. Intricate machines do the actual assembly with uncanny dexterity. The component parts are fed in and high-pressure gas jets are used for molding and trimming the glass. The tungsten wire, now coiled, is accurately clamped into position, and the filaments are now practically ready to be fitted into the glass globes, which are first thoroughly washed to remove any chemical impurities. The bulbs, still open at the base, are placed over the filament sections in quick time prior to being sealed. The bulbs, exhausted of air and filled with the mixture of argon and nitrogen, are now fitted with the caps which will eventually fit into the bayonet socket in somebody's home. some metal, some glass, a bit of gas, and there you are. Couldn't be simpler. Not so unusual is a concrete mixer, except that in this case it provides the raw material for a unique concrete boat. It is a boat which looks the same but is made from a special formula called secrete. Surprisingly enough, the idea is not so new because between 1917 and 1922, due to shortage of steel during and after the war, concrete ships from tugs to oil tankers were built and used. But the idea, for many reasons, never caught on until exhaustive laboratory research resulted in a remarkable formula which enabled the first motor yacht to be built at this famous boat builders at Wroxham in Norfolk. It is, of course, only the hull that is made of secrete, and, incidentally, the mere fact that it needs no supports or cross-bracing illustrates its superior strength to a wood or glass fiber hull of similar size. Being, in fact, as strong as steel, although much lighter, the absence of internal frames means much more free space inside than usual. The whole yacht can be turned out in 3 weeks and will never need maintenance. On top of all that, it actually works.
But this is Derbyshire. This cave is Castleton, a cave where Bert Madison, 78 years old, is the last of a line of rope makers stretching back 200 years. Bert has plodded the length of this rope walk since he was 12. It's a sad walk now, the twilight of the rope walk, for there's no one to follow him. Once, 30 people made rope here, but the demand for craftsmanship has decreased, and craftsmen are lonely men. That's a tow rope he's making from hemp, a rope made by the Madison method that Bert promised his father he'd not see forsaken. A father whose answer to the cave's damp cold was human work to keep warm, but icicles persuade otherwise. A friend helps Bert, for rope making can't be accomplished alone. But he's alone in his thoughts of the past, before machines, before a world where speed laughs at old, gentle skills. Remnants of this Castleton craft lie scattered about the dim-lit cave, but the past shows most clearly in Bert Madison, the last of a proud line.
The face of the countryside is changing. New big motor roads are under construction, the bulldozers making deep and dirty marks across the map. What are the map makers doing to keep pace with these breathless changes? Well, here's an instrument that actually put them ahead of the motorway engineers, the tellurometer. It works like an echo sounder, sending out high-frequency signals, measures distances of 30 miles. With it, 4 men measured a 6-mile baseline in 2 days in a job that took 42 pre-war surveyors nearly a month to do with the old tripods and steel tapes. It used to take 2 men a whole year to do the map-making mathematics that these adding machines and electronic computers can do in an afternoon, with a girl to help. You know how you can take 2 flat snapshots and look at them through a gadget that turns them into 3 true-life dimensions, stereoscopic vision? Well, the map makers do the same with this machine. Air photographs of mountains stand up in 3D, and a floating dot enables the viewer to trace every contour on the map at his elbow. Stereo plotting has made mountains into molehills as far as the hard grind of map making is concerned. Royal Engineer officers and nearly 4,000 Ministry of Agriculture officials are working at full pelt in the Ordnance Survey to record the changing face of Britain on those famous maps 1 inch to the mile. They also make maps of towns so big you can pinpoint the flowers in your front garden 3 bus lengths to the inch. Here's how they get those squiggles which show you the height of mountains. Draftsmen trace the lines the stereo plotters made on wax-coated glass, a process known as scribing a mold. Climbing these hills would be much less work than drawing them so accurately. The hand-drawn maps are photographed, and from the negatives a whole series of zinc printing plates are etched out. There's plenty of room for a dicky bird to fly out of this camera, and plenty of time. The exposure takes 3 full minutes. The printing stages are almost as complicated. Each time a sheet goes through these presses, 2 colors are printed. The ordnance map has 10 colors, including the novelty of mountain shading at the end of its 5th trip between the big rollers. Britain has led the map-making world, pioneering almost all the new processes. Today, every new mile of motorway puts some obscure, unknown part of Britain on the map. Baking a cake is not as easy as you might think, as more than one harassed housewife has discovered, usually on the day of some big party she's arranging. But forgetting for a moment those old jokes about the landlady's rock cakes, etc., let's explain now that this is not bad baking. It's merely a demonstration of what can be done with confectionery that has been frozen. For frozen confectionery, which will stay fresh for months, seems to be the current, if you'll pardon the expression, trend. Let's pay a visit now to a bakery at East Finchley, one of the industry's pioneers of deep freeze. This is the room where bread rolls are born, a process that is surprisingly interesting. Few people realize what goes on behind the scenes at this stage, so watch closely and see if you can pick up a few hints. As you can see, these days most of the work is done by robot machines, which are often as amusing as they're ingenious. After the dough has been thoroughly mixed, it's taken over to an even more remarkable machine that separates and molds it to the shape required. The next stage is the actual baking, and when this has been done, the rolls are allowed to cool for about half an hour at room temperature, about 80 degrees, before going into the deep freeze. Scientific tests have proved that the rate of staling is decreased by deep freeze, and that bread or cake can be left for between 4 to 5 months. But for practical purposes, 4 to 5 days is enough. Weekends and bank holidays, for example. The rolls will remain in the deep freeze at a temperature of around 10 degrees below zero. That is 40-odd degrees of frost, for as long as the baker wishes. Then they are allowed to defrost naturally at room temperature for periods of, say, 20 minutes to an hour for buns and small cakes, and 2 or 3 hours for bread or slab cake. Yet another example of the significant part science is playing in our everyday lives.